notes are about two main families. So you know in your tree how the family in the middle is the parallelogram family, right? If you look at your yellow tree, you have the parallelogram family in the middle. On the right is the trapezoid family, and there's two figures there. And then on the left is the kite family, and it's just a family by itself. So today we're going to do kite and we're going to do trapezoid. First thing that I want to talk about is all the different properties that you need to know for these figures. So first off, trapezoid. You guys learned trapezoids when you were in elementary school, maybe? Do you remember the big important thing, like what makes a trapezoid a trapezoid?
One pair of opposite sides are parallel.
Yeah, only one pair of opposite sides are parallel. So for trapezoid, you're going to put only one pair of parallel sides. Okay, and those parallel sides are called the bases. Now, I'm writing only one pair because what do you call it if there's two pairs of parallel sides? Parallelogram, right? Two pairs is a parallelogram, one pair is a trapezoid. Okay, so this is how you probably have seen a trapezoid. Looks something like this. You have one pair of sides that are parallel. These are called the bases. Okay, besides having one pair of parallel sides, you also know that the base angles, the non-base angles are supplementary. Okay, what I mean by non-base, I mean the angles that are not on the same base. So if we label them, 1, 2, 3, 4, what is the base angle with 1? Which angle is on the same base? 2. So what is the non-base angle with 1?
4.
Okay, 4 or 3. So in this case, you're going to say angle 1 plus angle 4 equals 180. They're supplementary. Likewise, angle 2 add angle 3. They're supplementary. So they're going to add to be 180. Okay, so that's a trapezoid. It might be intelligent for you right now. Take this. Do as Matt is doing and write it on your note sheet and on this yellow sheet, because eventually it has to go on the yellow sheet. Okay, an isosceles trapezoid is still within the trapezoid family, so it has all the same properties of trapezoid. But then it has 3 more. Now, what makes it isosceles is that the legs are congruent. Okay, so here's what I mean by that. If I draw myself a trapezoid where I have the bases that are parallel, the sides that are not parallel are called the legs. So if you have one pair of sides that are parallel and then one pair that are congruent, that's an isosceles trapezoid. Okay, so by definition, the legs are congruent. But then there's 2 other important properties. The second property is that the diagonals are congruent. Okay, diagonals congruent, that's a property of an isosceles trapezoid. What else is that a property of? A rectangle, yeah. Okay, and then the third important property of an isosceles trapezoid is that the base angles are congruent. So if we number them the same way as before, that means that angle 1 is going to be congruent to which other angle? Which is the base angle with 1? 2. Yeah, 1 and 2 are going to be congruent. Likewise, 4 is going to be congruent to 3. I cannot stress enough that that is only true in an isosceles trapezoid. It's not true in any other figure. Okay, questions on trapezoids? Okay, last figure for today is a kite. A kite is completely unrelated to a trapezoid. A figure can be a trapezoid, it can be a kite, it can't be both at the same time. And both of these are completely unrelated to parallelograms. Okay, definition of a kite is we have 2 pairs of consecutive congruent sides. Okay, so here's what I mean by that. Wow, just go with me. This is a horrible kite, but just go with it. So I have one pair of sides that are congruent and another pair that are congruent. What's really important is that they're next to each other. So in a parallelogram, they would be across from each other, and a kite, they're next to each other. Okay. Second property is that the diagonals are perpendicular. Besides being a property of a kite, what else is this a property of? Rhombus. Okay. The next two are kind of funky wording. So property 3 is that the angles between the non-congruent sides are congruent. Okay, so here's what I mean by that. This angle is in between the non-congruent sides. This angle is in between the non-congruent sides, so they're congruent. Okay. Next property. The diagonal connecting the congruent angles is bisected.
Are we allowed to write 4 of them here? Like, on the image?
There's only 3.
Yeah. I just didn't want to write more.
Yeah, so you can, yes. There is a more concise way to write these, but I like writing them this way. Okay, so this diagonal, which is connecting the congruent angles, this one is bisected. And actually, Jordan, to throw you off even more, I'm going to have you add a 5 too. Sorry. So you're going to have to add 4 and 5 to your property sheet. Okay, last one. The non-congruent angles are also bisected. So these angles that are not congruent, these are bisected. So this one is bisected. This one is bisected. So kite has a ton of properties. Yes, Colleen.
On our cheat sheet, can we draw?
Can you draw this stuff in the figure?
Yeah.
Yes. Thank you for asking. Yes, so if you would like to draw that in the figure on your tree, your figure tree, you can. Can I erase and move on? No, not yet. Okay. Do we have all of this written in at least one spot?
Yep.
Yes? Okay, because I'm not going to leave it up here just so you can write it twice. Everybody has it written in one spot, because if I erase it, it's gone and it won't come back.
I'm just drawing you through. We're good.
Okay, we're good. Hopefully the rest of you were good too. Okay, so examples 1, 2, and 3, we're going to calculate some angle measures. Before we just jump in and start calculating, first thing that we have to identify is what type of figure do we have. So, figure number 1. Does this fall parallelogram family, trapezoid family, or kite family? Trapezoid, right? One pair of parallel sides. What does this tell us? Isosceles trapezoid. Okay. So we're going to start with that. Now, in an isosceles trapezoid, we know that the base angles are congruent. So if this is 110, then angle H is also going to be 110. Now, how am I going to find F or G? Jordan?
Like you can do that 180 times 4 minus 2 to get what the angle measures have to be, and then you can subtract 220, and that's what you have to divide, like for the F and G.
Okay, yes, you could do it that way. There's a quicker way though, that I would prefer instead. Julia?
You could do 180 minus 110 because J and F are non-basic.
Mm-hmm. And that's a property of what?
Trapezoid.
Yeah, so if we go back to the trapezoid properties, we know that angle F add angle J, those are supplementary. So those are gonna be 180. That's a property of every trapezoid. So if this is 110, if I do 180 minus 110, I get this angle to be 70. Now again, the base angles are congruent because it's an isosceles trap, so I get 70 again. Jordan, your way definitely works. This way's quicker. Okay. Example number 2. What kind of figure is that? Kite. Kite. Okay. So one thing we know about a kite is that there's one pair of opposite angles that are congruent. In this case, are L and J congruent or M and K? L and J or M and K? M and K. Why?
Because the sides between non-congruent.
Okay, because they're between the non-congruent sides. Can't you also tell just by looking?
Yeah.
So non-congruent sides, so these angles are congruent. So if this is 88, then angle K is also going to be 88. Now, does that mean that angle J is 120? No. How am I going to find angle J? Nick?
Well, you just add everything up and then do 360 minus whatever you get.
Yeah, it's a quadrilateral, so the angles add up to 360. I'm going to need you guys to do this for me. Oh, wow. Thank you, whoever that was who said that. 64. So it's a quad, they add up to 360, so subtract everything from 360 and you get 64 degrees. Okay, example number 3. What type of figure? Kite. Kite again. Okay, one pair of opposite angles are congruent. This one's nice, we already know these aren't congruent, so these have to be congruent. So if I do 360 and I subtract 60 and I subtract 50, I get 250. So what you divide it by 2. So we get 125 and then another 125. How do we feel about this? Not too bad? Can I erase? Okay. So, the next figure is figure rats. It says, what is the perimeter of rats? And it tells us that RT is 24. First thing, what type of figure is it? Kite. Okay, so that we need to know. We need to know that it's a kite. Okay. RT equals 24. How am I going to mark that on the figure? Colleen? Yeah. Do you remember on a kite how one diagonal is bisected? So this one can't be bisected because they're not congruent. That means this one is. So if it's 24, I have 12, and I have 12. Now, I have 4 sides that I need to find. Really 2, because these are congruent and these are congruent. So if I start with this side over here, how am I going to find x? Pythagorean theorem, or? Well, you don't know any angles. Anna? We could do Pythagorean theorem. There's something that's going to be a lot quicker, though, if you can identify it. Yeah, what kind of triangle is this? 45, 45, 90? Because 2 of the sides are the same? Do you guys remember with a 45, 45, 90, it goes L, L, L root 2? So if I have 12, 12,
12 root 2?
12 root 2. Yeah. Would I get something different if I did Pythagorean theorem?
No.
No, it's going to be the same. Okay, so this other side that is 12 root 2 also. Okay, how am I going to find an ST now?
Same thing.
Special right triangles?
Yeah.
Yeah? What type of special right triangle is it?
45, 45,
Really?
I feel like that's wrong.
Damien, is this a 45, 45, 90 triangle? Could it be?
No.
You're not convinced, I don't think. Ross, could this be a 45, 45, 90 triangle?
Yeah.
It could, in some world. Yeah, Jules, you agree? Can anybody convince me, yes, this could, or no, this could not?
No, it can't.
Because two sides are not the same.
Yeah, what do you know about a 45, 45, 90 triangle?
Two of them added to one.
Two sides have to be the same. Is it possible that this is 45, 45, 90? No, two sides are not the same. Okay, so I can't do 45, 45, 90. 30, 60, 90? No. Pythagorean theorem, yeah, I don't know why we always forget about that one. Okay, so here's my right angle. So the side I marked as y is my hypotenuse. So I'm going to get 20 squared plus 12 squared equals y squared. So this is 400, add 144. So I get 544 equals y squared. I love to break down some radicals, so let's break this down. I would venture to guess that 4 goes into 544. Somebody tell me how many times?
36.
136? Okay, 136. 4 is going to break down to be 2 and 2, so I have a pair. 136, I believe 4 goes into again. 34. So this 4 breaks down to be 2 and 2. 34 is 2 times 17, so those are both left over. 1, 2 from this pair comes outside. 1, 2 from the other pair comes outside. The 2 and the 17 that don't have partners stay under the root. So this ends up being 4 root 34. Okay, so this side is 4 root 34. This side is 4 root 34. Okay, ultimately the question was, what is the perimeter? So for perimeter, we have to add up all the sides. So we have 12 root 2 plus 12 root 2 plus 4 root 34 plus 4 root 34. Can I add all of these? Are they all like terms, all 4?
No.
Are you allowed to add these two?
No.
Not sure. You can only add if they have the same number under the root. So these two you can add. 12 root 2 and 12 root 2 is 24 root 2. These two you can add because they have the same number under the root. So that's going to be 8 root 34. The root doesn't change. That's it. You can't do anything else. You just leave your answer like that. Questions? No? Any questions on any of these properties? No? Do you guys get the point of this perimeter idea? Do you think we need to do another example? No? Can we just move on? Yeah? Okay. Good answer. Okay, one more thing that we need to talk about, and it's called the triangle mid-segment. Do you guys remember hearing mid-segment from triangles? Yeah, maybe. Do you remember what a mid-segment does?
Oh, it's like half base.
It's half the base. That's all we remember?
Parallel to that.
It's parallel to the base, yeah.
It makes the two sides parallel.
Okay, it connects. What do you call this point? midpoint. Okay, so a trapezoid mid-segment is going to connect the midpoints of the trapezoid legs. Connects the midpoints. It has two important properties. The first one is it's parallel to the bases. Second one is similar to a triangle, but a little bit different. The length of the midsegment equals the average of the bases. Do you guys know what average is?
Yeah.
Like, what's the average of 60 and 80? 70. You add them and divide by 2. So, example 6. How long is TS if we mark it with an X? 38.5 is our midsegment. It connects two midpoints. So the midsegment equals, so I get 38.5 equals the average of the bases. So average is going to be add them up, divide by 2. So 26 plus X divided by 2. How am I going to solve this? Colleen? Yeah. Inverse of dividing by 2 is to multiply by 2. So dividing by 2 and multiplying by 2 cancel. So I get 26 plus X. 38.5, I believe, is 77. Subtract 26, subtract 26. So I think I get 51. So our segment TS equals 51. Questions? Can I erase this? Yeah? Okay. Ideally, here's what we're going to do. We got 12 minutes and 2 more examples. So we're going to do these and then I'll give you a few minutes that you can start your homework. Example 7 we're just going to do together because of the interest of time. Can anybody tell me the setup for problem 7? Sophia?
2x minus 1 equals to 54 over 2.
Okay, so the mid-segment equals, I add my bases and I divide by 2. There's an easy way you can go from here or a hard way that you can go from here. What's the easy way to go from here? Abby? That's the hard way. But that still works, yes.
You just do 10 plus 44 and then divide by 2.
Yeah, what is 10 plus 44?
54.
54 divided by 2. 27. So I get 2x minus 1 equals 27. You could multiply by 2. That still works, but this way's quicker. Add 1 and I get 2x equals 28. So x equals 14. Okay. Last one is yours to do. Can you tell me what are the measures of angles U and S, or at least how to do it? I will take it from anyone.
Yes.
You want us to tell you?
I actually want you to tell me yes.
I had 132 and 62. Then subtracted from 60 and then divided by 2.
Okay, 132 and 62 is 194. 360 minus 194 is 166.
Then divided by 2.
Divided by 2. So 83 and 83. Okay. How do we feel about these properties? Okay. Can we look at the first example on your homework?
Yeah.
Just so that I know that you know how to do this. Okay. So this should begin on page 21. Okay, so page 21, problem 1, it says determine whether ABCD represents a trapezoid. How are you going to start? What? Graph it? Yeah. Okay, so determine whether ABCD represents a trapezoid. So what are you going to have to do from here? What is the definition of a trapezoid?
Opposite sides. One pair of opposite sides.
One pair of opposite sides are parallel. How can you tell parallel?
Slope.
Slope. So right now you're going to have to, how many slopes do I have to do?
2.
One.
Well, 4.
Okay, let's think about this.
Well, that's just fine.
If I have a figure and I only do 2 slopes, and I find my slopes to be 2 and 2, does this figure have to be a trapezoid?
No.
What could it be? Square. Parallelogram. Right? What if these slopes happen to be 4 and 4? Then what is it? Guys, look at your property sheet. Look at your property sheet. If these end up being my slopes, what type of figure is this? No. No. Can I see this, please? Okay, here's how this sheet works. You guys are just looking at it and just looking for random written answers. It works from the top. Is this figure definitely a quadrilateral? Yes. Based on those slopes, does it fall in the kite, the parallelogram, or the trapezoid family?
Parallelogram.
Parallelogram. Do I have any extra information to determine whether it's a rhombus, square, or rectangle? No. In fact, this is not a rectangle. Why? Doesn't have any right angles. Okay. So, do we see that if I find one pair, that doesn't necessarily make it a trapezoid? That it could be a parallelogram? So how many slopes do you have to do to prove that it's a trapezoid? 4. So you're going to have to do AB, and then you're going to have to do the opposite side, which is CD, and you're going to have to compare. Then you're going to have to do BC, and you're going to have to do the opposite pair, which is AD, and compare. You have the next 7 minutes to keep working on homework. I'll put the answer key up here for you.